Hi, myself Gautam Kumar T. I'm from Shiltesha College of Engineering. Today I'm going to explaining about classification of wind energy conversion systems. First, let us look into the contents. We start with the introduction. Next, we will go into the classification of wind energy conversion systems. There are many six types of wind energy conversion systems, starting with according to the axis rotation, according to the size as determined by the useful of electrical power output as per the types of output power wind aero generations as per the rotation speed of aero turbines. Wind turbine are also classified as per how the utilization of output is made based on which wind origination. We'll first look into the introduction. Wind powers are renewable energy resources that use wind turbines to generate electrical energy from kinetic energy of moving air. Wind power consists of sustainable and has a smaller environment impact but than the burning fossil fuels. Now let us look into the classifications. We first will start with classification based on axis rotation. There are mainly two types, that is horizontal axis wind turbines and vertical axis wind turbines. First is horizontal axis wind turbine. Horizontal axis wind turbines are most common types of wind turbines. The rotation shaft is parallel to the ground and the blade rotates around the horizontal axis. They resemble the traditional windmill design but I engineered from electrical generations. Vertical axis wind turbines. Vertical axis wind turbines are the types of wind turbines. The main rotor shaft is arranged vertically and the blades are around it. Unlike the horizontal wind turbines, uh, vertical vertical axis wind turbines do not need to be pointed to the wind and can capture wind from any direction. Now let us look into the next one according to the size as determined by the useful of electrical power. First we'll look into the introduction. Wind turbines are classified based on their size, which is determined by their useful electrical power. The classification helps in settling the turbines from specific application range from smaller registers to setting a larger unitary scale of wind farms. First, we look into small scale wind turbines. The main power output of these turbines is 100 kilowatt. Applications residential houses, small businesses, off-grid and remote locations. Features: compact designs, easy installation and maintenance, suitable for areas with lower wind speed. Example: micro wind turbines up to 1 kilowatt, mini wind turbines 1 to 10 kilowatts, small commercial turbines that is 10 to 100 kilowatts. Now let us look into the medium scale wind turbines. Power output is 100 kilowatts to 1 million watts. Applications: small industrial sites, commercial wind project, institutions using like schools, hospital. The main features of intermediate size and capacity, balance between cost and power generation, suitable for distributing energy generation. Now let us look into the large scale wind turbines. The power output is 1 MV and above. Application is utilize scale wind farm, use large industrial sites, grid connected renewable energy projects. Features is high power output, larger rotor diameter and tall towers. Advantage: advanced technology for efficient and reliability. Example: offshore turbines and onshore turbines. Now let us look into the another classification. As per the types of output power and wind aero generators are wind aero generators or wind turbines are classified based on types of electrical power output they produce. This classification is essential for determining suitable for wind turbines for specific application and integration with the power grid. Now let us look into the first one. DC, that is direct current. The characteristics of these DCs are processed directly processes of direct current electricity typically used for off-grid applications required a refinery or converter of connecting to a AC grid. Application: battery charging system, remotes, off-grid systems, small-scale residential and commercial application. Advantage: simple design, few components, ideal for storing in batteries and DC power devices. Now let us look into the AC. Alternating current outputs. Characteristics: product alternating current electricity, complexity with power grids. Common household applications can be single phase or three phase ACs, that is alternate currents. Applications of this AC output is grid connected system, large scale wind farms, industrial and commercial power supply. Advantages is integrated with electrical grid, suitable for large scale energy production and distribution. Now let us look at another classification, that is as per the rotor speed of aero turbines. Wind turbines can be classified based on the rotation speed, which influence their design, performance and suitability for different applications. Understanding this classification helps in selecting the right turbine for specific wind conditions and energy needs. Now let us look into the first one, that is fixed speed wind turbine. Characteristics is operates at a constant speed, generates of wind variations, simplified control and low maintenance required, often use squirrel cage generators. Application suitable for a location with constant wind speed. Historical common is easy wind designs. Advantage robust and reliable design, simpler electrical infrastructure. Now let us look at the various speed turbines. Adjusting rotational speed to match the wind variations, using power electrical to control generation speed and output, can achieve high efficiency and better performance. Applications suitable for wide range of wind conditions, common in modern wind turbine designs. Advantage improves energy capacity and efficiency, reducing mechanical stress and longer lifespan. Now let us look at another. Wind turbines are classified as per the how utilization of output is made. Wind turbines can be classified into how the electrical output is utilized. This classification includes battery storage, direction connection, and other devices form the electrical grids. Now let us look into the first one, battery storage. Wind generation generated electricity stored in batteries for large later use, commonly used in off-grid or remote applications, can improve backup power during periods of low windmills and high demands. Applications: residential homes, remote areas, small business areas and farms. Advantage: provides energy storage and construction supplies. Now let us look into the direct connection of electromagnetic devices. Wind turbines output is directly connected to the devices that utilize the electromagnetic energy, such as motors. It has simplifies the energy conversion by eliminating intermediate storage or conversion steps. Application: water pump systems, direct heating application, industrial process. Advantages: direct use of wind energies for specific application, reduces energy loss and with power storage and conversion. Now let us look into the another classification based on wind origination. Wind turbines can be classified on the how the origin related to the wind direction. This classification includes upper and downwards turbines. Now let us look into the first upper upwind turbines. The rotor faces into the wind, which the needle and blades position upward of the tower, requires a yard mechanism to align the rotor with wind direction. Application most common used in large scale wind farm, used in both offshore and onshore installation. Advantage: reduce turbines and shadowing effects of towers. Next is downwind turbines. The rotor is located on the downwind side of the tower. The wind passes through the tower before hitting the blades. Application suitable for certain nice application where flexible and stability are designed. Advantage: can eliminate the needs of yard machines. Blades can be more flexible, reduces load and high winds. Potential simpler and cheaper design. This is about the classification of wind energy systems. Thank you.